Hello, I'm Christopher Robeller and I'm presenting the paper HexBox Canopy, a segmented timber plate shell with hardwood wedge joints, which we developed together with the co-authors Eduardo De Oliveira Barata, Enrico Valentino Tagliaboschi, and Felix Schmidt-Kleespies. It was a project developed between student groups from the University of Sydney and the TU Kaiserslautern in Germany. So the big context for this project is basically, if you look at this image, that in timber construction, there was a time when we worked a lot with very smart geometry in joinery. And then during industrialization, when suddenly we didn't have the complexity in our fabrication anymore, we had to simplify things. Things were metal connectors that were basically pressed and mass produced. So we lost a lot of these very elaborate connections that we had before. And the trend that we're in right now is actually going back to these more elaborate connections like mortise and tenon joints and wedge joints. And this is something that we wanted to take to the domain of shell structures. And we took particularly inspiration from these X-Fix hardwood wedge joints, which is a very smart system where you basically hammer in a joint and through its X shape, it will tighten the connection gradually. And it has this particular possibility to close gaps and to really embed the precise assembly information for the parts through the cutouts. And then on site, you can just squeeze in the joint and it will pull everything gradually into its final position. It's especially important if you have a soft material like wood, which might warp and bend a little bit. So for the project that we're going to show you today, there is the robot that we could use at the University of Sydney, which you can see on this slide. And we got a site where we could build this little experimental structure. It was a project that we built together with 20 students from Germany, 20 students from the University of Sydney, and we had 1 week to finish the project on this spot on the balcony of the building of the architecture faculty of the University of Sydney. So we wanted to design a curved canopy here. And the big question in realizing this was, how do we realize this complex curvature? And we had to do it rather cheap. So we went for flat material, flat plywood sheets. And these flat plywood sheets have to be tiled on our curved surface, as you can see here. And we used this principle here, which gives us the pretty unique possibility of a three-dimensional offset, which is creating no gaps. So you can see there's some references in our paper to show you the previous research on this subject, but it basically changes its shape based on the positive or negative curvature of the surface from these hexagons to these bow tie shaped elements. So here you see the approach that our students took in realizing the joinery with these wedge joints. And this was the first experiments where we basically, within these hollow boxes that we built, made connectors. As you can see here, they're built from a part that is cutting through the two plates, and then a wedge is inserted from the top, and you can, just like with the X-Fix connectors, you can hammer it in. And our algorithm that we use to generate all of this geometry, it will automatically create all of these cutouts, and then the connector is always the same piece, but the hex boxes, these hexagonal timber boxes, they're all uniquely shaped. So the first thing we had to do was really build a prototype, because it was a project between Germany and Australia. So we wanted to have a complete test up and running and see if the tolerances work out mostly. So we produced our first prototype, which you can see here. We use 5-axis CNC cutting. And then our strategy for connecting these pieces was to use the Lamello Tenso system, which was supported by the company Lamello, which helped us a lot to realize this project. We cut out these cutouts into the box, and then these connectors help us with the gluing basically. And then box to box connections are not with glue, but just with these wedge connectors. So the very interesting thing about this first prototype was to see whether it has gaps, and luckily we could build it precise enough after some calibration of the machine, so we didn't have any problems with any gaps. So here you can see the fabrication in Sydney, which was carried out with a robot, but in exactly the same manner. And the actual pieces that we put together, you can see here that we created these connectors with like a batch assembly, and the final project was coming together, as you can see in these images, quite nicely. We are very proud that the project was even selected as a finalist for the Australian Timber Design Awards. And you can read more and all of the details about this project in our paper. So, flicking through these final images of the realized structure, I thank you for your attention. And this was a very exciting project. I hope that we can return to traveling and realizing international projects in the very near future. In the name of my co-authors and the entire team that you can see here, thank you very much for your attention.